গুড আফটারনুন। শোনা যাচ্ছে আমাকে?
ইয়েস স্যার।
নাম তোমার?
সহেলি চৌধুরী।
বাড়ি কোথায়?
জনাই।
আচ্ছা, তোমাদের দুপুরের ক্লাসটা হয়েছে তো?
হ্যালো স্যার।
দুপুরের ক্লাসটা হয়েছে কমিউনিটি ফার্মেসি?
হ্যালো।
হ্যাঁ স্যার।
আচ্ছা,
হ্যাঁ স্যার হয়েছে।
ঠিক আছে। Our today's discussion is acid, bases and buffer. তোমরা কি এই বছরই সবাই হায়ার সেকেন্ডারি পাস করেছো?
হ্যাঁ স্যার।
না স্যার, আমার এবারে গ্র্যাজুয়েশন কমপ্লিট।
আচ্ছা, কি নাম?
না স্যার, আমার এবারে গ্র্যাজুয়েশন ফার্স্ট ইয়ার।
স্যার আমার সহেলি নাম।
সহেলি, আচ্ছা। তাহলে তো তোমরা এইগুলো আগেই তোমাদের জানা রয়েছে, জাস্ট রিপিটেশন হবে, তাই তো?
ইয়েস স্যার।
কেমিস্ট্রি পার্টটা তোমাদের রিপিটেশন হবে, কারণ হায়ার সেকেন্ডারি করলেও এখানে খুব বেশি তার থেকে টাফ কিছু নেই। কতগুলো শুধু ফার্মাসিউটিক্যালসের স্টাডি করা ছাড়া বাকিগুলো অনেকটা কমন। You have any idea about the pharmaceutical chemistry, this term? What does it mean? Clear from the name itself that it is the chemistry of pharmaceuticals. Chemistry of pharmaceuticals. Now, what are pharmaceuticals? Pharmaceuticals are those chemicals which are being used in the manufacturing of drugs and cosmetics. So they are unitedly called as pharmaceuticals. So it is the chemistry of pharmaceuticals. So it is obvious that it is not at all different from your inorganic, organic, physical chemistry, what you have taught during this period. Only thing, some specific characters, some specific method of preparations of the important pharmaceuticals which are in the syllabus that you have to study. So in this first year curriculum, we have the inorganic pharmaceutical chemistry, and in the second year, the organic pharmaceutical chemistry. So inorganic pharmaceutical chemistry means the branch of that pharmaceutical chemistry which deals with the inorganic substances which are used as a drug or in the preparation of drugs and cosmetics. Acid, bases, and buffers are very important inorganics which are being used in the pharmaceutical industries in the preparation of pharmaceuticals. So all this general part is known to you, that what was the earlier concept of an acid? How before the concept of Arrhenius, acid was being defined. At that time, acid means it was a substance having sour taste and its aqueous solution can turn blue litmus red. That substances are being called as acids. And bases are those substances having bitter taste and whose aqueous solution can turn red litmus blue. It was the earlier concept of acid and bases. But slowly and slowly, the chemical concept of this acid and bases are being developed. And the first one of this kind was the classical concept of Arrhenius, or Arrhenius concept of theory of ionization. This concept of acid and base was the first of this kind of chemical concept introduced by Arrhenius. And according to him, an acid may be defined as any hydrogen containing substance, the substance which can give hydrogen ions in its aqueous solution. So aqueous solution is mandatory here. If the substance is not soluble in water, then this concept of Arrhenius will not be applicable for such substances, and you cannot define that substance whether it is acid or base or not. So one thing of Arrhenius concept is that the substance in its aqueous solution, if it can donate or it can give hydrogen ion, it ionizes and gives hydrogen ion, then that substances will be called as an acid. And if the substance in its aqueous solution can produce hydroxyl ions, OH minus ions, then the substances will be called as base. So you can take one common example, HCl. When you are making a dilute solution, aqueous solution of HCl, it will produce H plus ions. So HCl is an acid. If you take NaOH, in its aqueous solution, it will produce OH minus ions, hydroxyl ions. So it is a base. Now, Arrhenius also stated that it was earlier known that in the neutralization reaction, water and salt is formed when the acid and bases are taking part in a neutralization reaction. How it is formed? From this concept, from the concept of Arrhenius, it is clear that the hydrogen ion which is formed by the acids in its aqueous solution and bases, they produce hydroxyl ions, OH minus. This H plus and OH minus ions are responsible for the formation of water in the neutralization reaction. And the remaining part of the acid and base, they combine together by forming bonds to produce salts. In a generalization way, we can write it in this way. HA, if HA is an acid which has hydrogen in it, hydrogen, and BOH the base, then in neutralization reaction, it will produce Ba, that is the salt, B plus A minus, and H2O, coming from this H plus and OH minus ions. And the degree of ionization of that substance in its aqueous solution determines its strength. One acid, one substance, you are defining it as an acid because it in its aqueous solution can produce hydrogen ion. Now, what is its strength? Strength means it is of two classes. Either it is a strong or it is a weak category of acid. That is the strength of the acid. And that strength is determined from the degree of ionization. If the degree of ionization is very high, immediately it produces a lot of hydrogen ions in its aqueous solution, then we'll say that this acid is a strong acid. But if the acid is slowly ionizes in its aqueous solution, or its degree of ionization is partial, not full, then we'll call this acid as a weak acid. This is in a small Arrhenius concept of acid and bases. It has some limitations. It has some limitations. Number one limitation is that from the definition, it is clear to you that for defining a substance as an acid or base, you need aqueous solution. The substance must be soluble in the aqueous media, that is the water. So if the substance is not soluble, or if it is soluble in any solvent, which is organic solvent, not water, then this definition will not become. That is one limitation of Arrhenius theory of ionization or acid-base concept. Second is, this theory is also not able to explain acidic or basic properties of a substance in non-aqueous solvent. Say, for example, ammonium nitrate, if it is in liquid ammonia, dissolved in liquid ammonia, it is observed that ammonium nitrate behaves as an acid. In presence of ammonia, it behaves as an acid. But as far as Arrhenius theory of ionization is concerned, it will not be considered as an acid because it is not capable of producing hydrogen ion in that solvent. এখনো enter করে যাচ্ছ। And the third limitation, if your acid and base is present but without any solvent, then the neutralization, which is as far as Arrhenius is concerned, Arrhenius stated that this neutralization of acid and base produces water by combining the hydrogen ion and hydroxyl ion produced by them in the aqueous solution. It is not coming here because here you don't have any solvent. So you cannot explain the neutralization of acid and base in absence of solvent. That is one limitation of Arrhenius concept. Another limitation, the basic substances which do not contain hydroxide ions, hydroxyl ions, they could not be explained by this theory, because the theory said that the bases will have the capability of producing hydroxyl ion in aqueous solution. Then only you can say it a base. So the basic substances which do not have, like ammonia, NH3, don't have any OH. So as far as the Arrhenius definition is concerned, it will not be treated as a base. So this is another limitation. And the last limitation here, that it cannot explain the acidic character of some salts like aluminum chloride, AlCl3, or say carbon dioxide is a acidic oxide, sulfur dioxide is acidic oxide. They don't have any hydrogen. They don't have any hydrogen, so they will not be able to produce hydrogen ion in aqueous solution, in aqueous media. So these are the limitations of Arrhenius' theory of ionization. Next important theory put forward by Bronsted and Lowry in the development of acid-base concept. Bronsted and Lowry, they independently proposed a general definition of acid and bases. And according to this Bronsted and Lowry theory, an acid is any substance that is a molecule or a cation or an anion that can donate a proton to any other substance. That means from the aqueous solution producing hydrogen ion is shifted slightly. Here, they said that the substance which can donate proton to any substance, then the substance which has the ability to donate proton will be called an acid. That means an acid is a proton donor and a base is a proton acceptor. So that is the definition of acid and base as per Bronsted and Lowry. So when a compound, when a substance, a molecule is producing a proton in a media, the remaining part of the molecule, if the molecule is HA and it produces H plus proton, so the part remaining is A minus. This part, the term is as conjugate base. As per the Bronsted and Lowry theory, one acid means only those substances, that means the molecule or cation or anion, which has the ability to donate proton are called acids. And after donating proton, the remaining portion of the molecule of the acid compound will be termed as conjugate base. Am I clear? So if HA is the molecule of acid, when H plus is released or donated, the remaining part A minus will be termed as conjugate base. Thus the conjugate of an acid is the substance formed by the loss of proton. So a Bronsted acid ionizes to a proton and a conjugate base. This conjugate, this proton, this H plus, which is donated by the Bronsted and Lowry acid, it will then be added to a base. It will be added to a base and a conjugate acid of the base will be formed. Say B is the base. B is another base. This base means it is also defined by Bronsted and Lowry. What is a base? As per Bronsted and Lowry, base is a substance, that is a molecule or a cation or anion, which has the ability to accept a proton. Let B is a base that is also present in the same media and it has the ability to accept a proton, then only it will be called a base. So B is taking the proton H plus from the media. So it will be BH plus. This BH plus, after joining B and H plus, this BH plus will be called as a conjugate acid. So this previously I have told you conjugate base, the A minus, HA let HA is an acid, H plus relieved from it. So A minus remaining, this A minus is called conjugate base. And the H plus, which was donated by HA in the media, that must be accepted by, one substance must be present there who will accept it. Donate and accept, both will go side by side. Hand in hand they have to be. Otherwise, the system will not run. So this B, a base which is present there, it will accept that H plus and it will be converted into BH plus, a conjugate acid. So it must be clearly understood that an acid cannot exhibit its acidic property. Acidic property means to donate proton. This property it cannot exhibit unless and until there is some substance, there is some molecule which accept the proton released by the acid. Clear? So acid, base, both must be present at the same time in this medium. So if both the reactions we join together, the reaction will be such that HA, let HA is an acid, B is a base, and the reaction will be like that. This H will be donated by HA, so H will come to B. B has the capacity to accept a proton. It will be converted into HB. So B is, if I give you the reaction and ask you which one is base, who has accepted the proton? This B. So who can accept the proton? He will be called base as per Bronsted and Lowry. So B is Bronsted and Lowry base. Who has donated the proton? HA. And as per Bronsted and Lowry, the substance which can donate a proton, which has the ability to donate a proton, it will be called an acid. So it is acid. And after donating the proton, the remaining part of the acid is called conjugate base. And when base is joined with a proton, it is called a conjugate acid. So HB is conjugate acid of the base B, and A minus is the conjugate base of the acid HA. Now, in this way, if I write or if you see a lot of reactions you can write from different acid and bases, you will see in sometimes you will find that a particular compound, a particular molecule behaves both way. In one reaction, it accepts a proton. In another reaction, it donates the proton. So this accepting and donating proton, say for example, H2O and HCl, when hydrogen chloride gas is mixed with water, you will see that here HCl ionizes in the aqueous media, produces H plus and Cl minus ion, H plus and H2O combined produces hydronium ion, H3O plus, and chloride ion. Again, if you mix ammonia in water, H2O plus NH3, what will happen? NH4 plus, H plus ion from the H2O will come out, and this proton will be accepted by this ammonia. So it will form ammonium ion NH4 plus and OH minus. So water acting as an acid because it is donating the proton. H2O plus NH3 here, H plus proton is donated by water. So who can donate proton is called acid. So H2O is an acid here. But here you see HCl donated the proton H plus, which comes to water and water accepts it. So who can accept a proton in the media is called a base. So here water behaves like a base, proton acceptor. Here it is proton donator. So by these two reactions, you can easily show that water is a compound which has both the characteristics of acid and base. It can donate proton in some reaction. It can accept proton in some reactions. And the compounds which has this type of qualities or abilities, they are called amphoteric substances. Or if they are solvent, then we call them amphoteric solvent. or amphiprotic. So amphoteric or amphiprotic. So there is a slight difference is also there that I will tell you later when we'll complete the Lewis acid base. So amphoteric or amphiprotic, what does it mean? Some solvents like water, ammonia, glacial acetic acid, formic acid, they have the ability to behave the dual role. In some reactions, they are able to donate proton. In some reactions, they are able to accept proton. And this type of solvents are called amphiprotic solvents or amphoteric substances or solvents. Bronsted acids, they are also very in strength, and the strongest acids, say HCl, H2SO4, the strongest acids have the weakest conjugate base. That means let HCl is very strong acid. You know, already I have told you the strong acid means it has the ability to dissociate or donate proton very fast or fully. Total proton it can donate. So entire HCl will give the H plus, it will remove the H plus and convert it into Cl minus. Then this acid will be called strong acid. And you know that after removing the proton, the remaining part is called conjugate base. So Cl minus is the conjugate base. It is observed that the strongest acid have the weakest conjugate base. Why? That means chloride ion is the weakest conjugate base. Why? Because why HCl is very strong acid? When it will be strong? Strong acid means which can donate proton very fast and fully. That means Cl minus and H plus in HCl, their attraction is not very high, very strong. It is very loose. That is why HCl can easily donate the H plus ions very fast. So if Cl minus cannot bond very strongly the H plus ions, when Cl minus itself present in the media as a conjugate base, surely it will not attract H plus very fast, very strongly it will not attract. Because the attraction is not very strong, that is why H plus is removing from HCl. So Cl minus is a very poor acceptor of proton, and that is why it is weak conjugate base. This type of question may come to you, that why this conjugate base of a strong Bronsted acid is a weak conjugate base. Similarly, if your base is very strong, say NaOH, completely ionizes, OH minus it keeps in the media, then the conjugate acid which will be formed by it, that will be weakest conjugate acids. Bronsted and Lowry concept of acid and base, it also has some limitations. What are the limitations? Number one, proton transfer. That is the main concept here in the Bronsted and Lowry, that some substance will donate the proton and some substance will be there to accept the protons. The substance which can donate are acids, the substance which can accept are bases. So this excessive emphasis on the proton transfer, but there are some acids which are not protonic in nature at all, protoninae. So, but they are behaving like an acid. So their nature, their characteristics cannot be explained by this Bronsted and Lowry concept, Bronsted and Lowry theory. Second point, a large number of acid-base reactions are known in which no proton transfer takes place, like SO2, say acid 1 plus again sulfur dioxide acting as base 2. One sulfur dioxide is donating proton here, another is accepting, and the react products are SO2 plus and SO3 minus, 2 minus. So SO2 plus and SO3 2 minus, these are the products. Here one SO2 acting as acid, which accepts the electron, and another donates the electron. So in that way, this type of acid-base reaction cannot be explained because here proton is not being transferred. And Bronsted-Lowry concept is based on the proton only. Second, বর্ষা মাইতি, বর্ষা মাইতি, বর্ষা মাইতি জয়েন করেছো? শোনা যাচ্ছে আমার কথা?
ইয়েস স্যার।
এত দেরি করে কেন?
আগেই ছিলাম, নেটওয়ার্ক প্রবলেম ছিল, আবার নতুন করে জয়েন।
So the protonic definition cannot be used to explain this type of reaction because here proton transfer is not happening. আমি আজকে অ্যালাউ করে দিচ্ছি, বাট now the third or the another concept of acid base, Lewis concept. Like Bronsted-Lowry concept was proton transfer concept, here it is electron donor acceptor system concept. Seeing the limitations of Bronsted and Lowry, Lewis concept was based on electronic configuration and electron transfer. According to Lewis, an acid may be defined as any species, molecular, radical, or ion, that can accept an electron pair. Sir, good evening. Sir, class nichi sir এখন আমি। আচ্ছা। So, according to Lewis, an acid may be defined as any species that can accept an electron pair to form a coordinate bond. And base may be defined as any species that can donate an electron pair for the formation of coordinate bond. So here, electron pair accepting and donating is the fundamentals between the acid and base. One molecule which can accept the electron pair for the formation of coordinate bond is called an acid, as per Lewis's concept. And the substances which can donate an electron pair for the formation of the coordinate bond, that will be termed as a base. And in case of in the neutralization will be explained by Lewis is simply the formation of a coordinate bond between an acid and a base. It is the neutralization. Neutralization means acid and base, they will be combined together by forming a coordinate bond. For the coordinate bond formation, one substance or one molecule has to donate the electron pair. The substance which is donating the electron pair is called a base. And when it is donating, someone has to accept it. Who will accept? That substance will be called an acid, and there will be a formation of coordinate bond, and that is the neutralization. Say H plus and NH3. You see NH3, it has a pair of electron pair. This electron pair will be given to H plus. So it will form NH4 plus. This is called adduct. In the Bronsted-Lowry, we have got the terms like conjugate acid, conjugate base. A base is formed a conjugate acid after joining with the proton, and an acid after removing its proton forms conjugate base. And here the acid and base, after joining together by formation of coordinate bond by sharing the pair of electron, one is giving and another is taking it. This joined after joining, this is called an adduct. So NH4 plus is an adduct. BF3, NH3, they combine together by the coordinate bonding. You see then they will form BF3NH3. It is an adduct. So Lewis acids are H plus, NH4 plus, Na plus, sodium, potassium ions, Cu2 plus, Al3 plus, carbonium ion. They're all Lewis acids, examples of Lewis acids. And Lewis bases, ammonia, water itself a Lewis base, hydroxyl ion, chloride ion, cyanide, sulfide, etc. Now, this is the three most important concept of acid and base. Now, if you see that the Bronsted acids, if you see all the Bronsted acids, they are Lewis acids. All Bronsted acids are Lewis acids because the proton from any proton donor, whenever proton donors are called acids there, proton donors, they coordinated with unshared electron pair. And that is why they are fulfilling the definition of Lewis. So all the Bronsted acids are Lewis acids. Whenever they are donating the proton, they are forming a coordinate bond with the unshared electron pair for the formation of its conjugate base. But all the Lewis acids, the reverse is not true. All the Lewis acids are not Bronsted acids because the acids which cannot donate any proton, which don't have any proton, they will not be Bronsted acid as per the definition of Bronsted, but they can be acid by accepting electron pairs of the bases. That is why they are Lewis acids, but they are not Bronsted acids. So all Bronsted acids are Lewis acids, but all Lewis acids are not Bronsted acids. Similar is the case of the Bronsted bases. All Bronsted bases are Lewis bases, but all Lewis bases are not Bronsted. Any question? Limitations. What are the limitations of Lewis acid-base concept? Since the strength of the Lewis acid and base is found to depend on the type of reaction, it is not possible to arrange them in any order of their relative strength. And second is, as Lewis acid-base reactions involve electrons, they are expected to be very fast reactions. But in practice, it is found that there are many Lewis acid-base reactions which are not so fast. They are slow. And that is also a limitation of Lewis acid-base concept or electron transfer concept. Another concept is Pearson's HSAB principle or hard and soft acid-base concept. HSAB, hard and soft acid-base concept. This concept was developed by R.G. Pearson. Pearson accepts the Lewis concept of acid and bases, and considering this concept, it provides a qualitative view of various factors for determining hard acids, soft acids, hard base, soft base. But the definition of acid and base is taken from the Lewis. So this Pearson, he actually categorized the acids and bases according to the properties. What are the properties on which this classification or categorization has been done? Charge, size, ionic radius of that compound, polarizability, etc. And it is observed that some of the Lewis acids and bases do not rigidly fit in the criteria of Pearson. Whenever he found that some of the acids, Lewis acids and bases, they do not rigidly fit with the criteria of the hard and soft acids as has been defined with the categorization from the properties like charge, ionic radius, polarizability, then that acids and bases, he classified them as borderline acids or borderline bases. So in that way, he actually categorized all the acids into 3 categories: hard acids, soft acids, borderline acids. All the bases into 3 categories: hard bases, soft bases, borderline bases. Okay. And it is observed that hard acids, which are hard acids according to Pearson, according to HSV principle, those acids having those electron acceptors having high positive, relatively small size and unfilled valence shell orbital. That leads to high electronegativities and low polarizability. They are considered as hard acids. Okay. And soft acids, they are also electron acceptors. Acid means electron acceptors, but they having low positive charge, relatively large size, but their valency orbital shell are filled and leading to low electronegativities and high polarizability. On the other hand, hard bases, they are electron donors having high electronegativities, easily reducible, stable valence shell structure, low polarizability. Soft bases are electron donors having low electronegativities, easily oxidizable, empty, low-lying orbitals, and they having polarizability. What are borderline? Some borderline acids, their examples are like this, means those acids which are not fitting these 2 definitions of hard acids and soft acids. Pearson classified them as borderline acids. They are like Fe2+, Cu2+, Zn2+, Sn2+, Pb2+, Sb3+, Bismuth3+, and like this. And borderline bases are bromide, sulfate ion, pyridine, aromatic amine. These are the borderline bases. So you keep in your mind a general rule that more stable adduct means, when neutralization, in the neutralization, acid and base combine together by coordinate bonding in the Lewis acid-base neutralization reaction. This combined is called adduct. The general rule is more stable adduct are formed when the neutralization has been done by hard acids and hard bases, or soft acids and soft bases. If soft acids, soft bases combined by neutralization reaction, they will form a stable adduct, or hard acid, hard base, stable adduct, but not otherwise. And the relative stabilities of various adducts depend upon the relative hardness or softness of the acids and bases involved. Another thing, keep in your mind that monoprotic acid, polyprotic acid. If one proton is there in the acid and one proton is donated, so it is monoprotic, otherwise it is polyprotic. Strength are of 2 categories, either it is strong or weak. Strong acid, weak acid. Strong acid means when it ionizes or it produces the proton in a completely, efficiently. And if the strength of an acid or base refers to the efficiency with which the substance demonstrates the properties of an acid. So strong and weak. Obviously, strong acids and base means strength means what? Means that it completely dissociated in dilute aqueous media. That will be strong acid. In case of base also, if in its aqueous media, it is completely dissociated to form the anions, hydroxyl ions. So it will be, or it can accept proton efficiently, completely. And if it is partially, then it will be weak acid or weak base. So in a reaction, if you see, whenever in a reaction, it is not completely dissociating. Say in a dilute acid, dilute HCl in the aqueous media, it partially dissociated because it is highly diluted. So in this type of partially dissociation, whenever occurs, the reaction becomes reversible. Both ways it is happening. And in this type of reversible reaction, you know that you can find out the dissociation constants. And the dissociation constant, if you say it is Ka for acid dissociation constant, say acid is dissociating, HCl is dissociating H plus into Cl plus Cl minus. So Ka will be equal to what? if your acid is HA, or if your acid here is BH, if it's BH is a weak acid and it is dissociation is taking place, so H plus B minus will be the product. So dissociation constant Ka will be equal to B, concentration of B, into H plus by BH plus, concentration of BH plus. That is the dissociation constant, and this dissociation constant will give you the idea of the strength of the acid or base, and from that we can determine the strength, we can determine pK, pKb values, pH, etc. That will be discussed in the next class. So dissociation constant, that you understand how dissociation constant can be calculated. What is the time now? 4:04. Say H2SO4 is there. Now tell me, on ionization, on donating proton, H2SO4 gives you H plus and HSO4 minus. Now H plus is the proton. HSO4 will be termed as, hello, শুনতে পাচ্ছ?
হ্যাঁ স্যার
HSO4 কে আমরা HSO4 কে আমরা কি বলবো? As per Bronsted and Lowry concept, আমরা যে ডিসকাস করলাম, let H2SO4 একটা অ্যাসিড, by donating proton, it donates proton H plus and you got H plus plus HSO4 minus. এই HSO4 minus কে আমরা কি বলবো? Exactly, বলো আর একটু।
Conjugate base.
Conjugate base. In this way, you can write down a lot of conjugate bases. Conjugate base, when reacts with, it added with, কার সঙ্গে add করবে? In a pair of acid-base reaction, what happens?
Salt and H2O produced.
One acid and one base, when they react, they produces conjugate acid and conjugate base. Pairwise যাবে তো, না? এটা আমরা এইভাবে দেখাতে পারি। ধরো অ্যাসিড আমরা HA ধরা যাক একটা অ্যাসিড, and one base is let B. আমি একটু পরে ফোন করছি, হ্যাঁ একটু পরে ফোন করছি। তো it will produce, কি তৈরি করবে, কি তৈরি করবে বলো?
HB প্লাস A মাইনাস, মানে
এক্স্যাক্টলি
কনজুগেটিভ অ্যাসিড হবে HB আর A মাইনাসটা হবে কনজুগেটিভ বেস, কারণ প্রোটনটা ওখানে করছে।
হ্যাঁ, তার মানে HA ছিল অ্যাসিড, অ্যাসিড থেকে যখন প্রোটন বেরিয়ে গেল it will converted into conjugate base, so A minus is the conjugate base of HA acid and HB plus is the conjugate acid of the base B, তাই তো? এই পার্ট নিয়ে আর তোমাদের কোনো কোশ্চেনস আছে?
স্যার তাহলে ওই যে HSO4 মাইনাস যেটা কনজুগেট বেস হলো, তাহলে ওটা যদি আমি আবার বেসে আনি তাহলে ওটা কি দাঁড়াচ্ছে?
এটা তো বেস হয়েই আছে, কনজুগেট বেস তো এটা।
আচ্ছা
এটা অ্যাসিড হয়ে যেতে পারে আবার।
আচ্ছা,
এটা বেস, এটা আবার যদি প্রোটন অ্যাকসেপ্ট করে it will be converted into acid.
ওকে স্যার।
সো তিনটের মধ্যে ডিফারেন্স যেটা, সেটা শুধু তোমার বুঝে রাখলেই হলো। একটার ক্ষেত্রে আমরা ইলেকট্রন দিয়ে করছি, দ্যাট ইজ ইন লিভিস। বন্ডস্টেটে আমাদের প্রোটন কনসেপ্ট, এন্ড আরহেনিয়াসের কনসেপ্টটাও অনেকটা এখানে এসছে। ওখানেও তো হাইড্রোজেন, কিন্তু উনি বললেন এটা হাইড্রোজেন আয়ন দেবে ইন দি অ্যাকুয়াস মিডিয়াম, আর এখানে অ্যাকুয়াসের প্রশ্নটা রাখলো না ব্রন্ডস্টেট। সো দিস আর দি ডিফারেন্সেস বিটুইন দিস থ্রি। অ্যান্ড এই তিনটে পরে আমরা ডিসোসিয়েশন কনস্ট্যান্ট, পিকেএ, পিকেবি, পিএইচ ডিটারমিনেশন এবং এগুলোর কিছু প্রবলেম করব। তারপরে আমাদের কিছু স্পেসিফিক অ্যাসিড, বোরিক অ্যাসিড অ্যান্ড আরো ফিউ অ্যাসিডস আর দেয়ার ইন দ্য সিলেবাস, সেগুলো আমরা করব। তোমরা সিলেবাস তো পেয়ে গেছো পুরোটা, তাই তো?
হ্যাঁ স্যার।
তোমরা বইয়ের নামও পেয়ে গেছো।
স্যার একবার স্যার বইয়ের নামটা বলে দেবেন?
বইয়ের নাম বলতে তোমরা ওখানে কি আছে আমি দেখিনি। তোমরা জিআর চ্যাটওয়ালের বই দেখতে পারো।
স্যার আরেকবার বলুন, শুনতে পেলাম না।
জিআর চ্যাটওয়াল,
জিআর চ্যাটওয়াল, ওকে স্যার।
Pharmaceutical Chemistry Inorganic, Volume 1, G.R. Chatwal.
GR
G.R.
চ্যাটওয়াল।
CHATWAL। আর একটা ছোট্ট বই, এটাও ভালো দেখতে পারো, NC চৌধুরী অ্যান্ড গুরবানি।
কি স্যার একবার বলেন?
আরেকবার বলুন।
NC চৌধুরী,
NC চৌধুরী
অ্যান্ড NK গুরবানি।
ওকে গুরবানি, ওকে স্যার।
মোহাম্মদ আলীর একটা বই আছে। সবটাই খুব মানে তোমার খুব বড় করে পড়বার দরকার নেই, ছোট এই বইগুলোই তোমাদের সাফিসিয়েন্ট, এটা পড়লেই যথেষ্ট হবে। আর আমাদের নেক্সট ক্লাস হচ্ছে কেমিস্ট্রি আছে বুধবারে।
ওকে
ওকে ওকে
আর কোনো কোশ্চেন থাকলে তোমাদের করতে পারো।
নো স্যার।
আমাদের কিন্তু একটা হলো, তোমরা তো শুনেছো যে 75% অ্যাটেন্ডেন্সটা ম্যান্ডেটরি,
হ্যাঁ স্যার।
কিন্তু এখনকার এই সিচুয়েশনে ক্লাস তো কমই করতে হচ্ছে, দুটো করে ক্লাস আমরা হয়তো রেগুলার করছি। প্র্যাকটিক্যাল নেওয়া যাচ্ছে না, প্র্যাকটিক্যাল হয়তো আরো কিছুদিন পরে থেকে কিভাবে গভর্নমেন্টের কি ডিসিশন আসে দেখা যাক। সেগুলোর জন্য আমাদের এখন প্রথমে যেটা চেষ্টা থাকবে যে অ্যাজ ফার অ্যাজ পসিবল যদি থিওরিটাকে তাড়াতাড়ি শেষ করে রাখা যায়, তাহলে যখন কলেজে যাওয়া অ্যালাউ করবে তোমাদের, সেই সময় প্র্যাকটিক্যাল গুলো শেষ করে নেওয়া যাবে, তাই না?
হ্যাঁ স্যার।
আর তোমরা কলেজে গিয়ে লাইব্রেরি থেকেও বই নিতে পারো। তোমরা লাইব্রেরি কার্ড করে যখন যার সুবিধা মতো যাবে, কার্ড করে লাইব্রেরিতেও বই তোমরা নিয়ে আসতে পারো। ঠিক আছে?
ওকে স্যার।
ওকে, তাহলে আমরা আজকে শেষ করছি ক্লাস।
স্যার আমরা লাইব্রেরিতে এখন বই নিতে পারি?
হ্যাঁ পারো, তোমাদের অ্যাডমিশন হয়ে গেছে যখন, পারবে না?
মানে আমরা কলেজে গিয়ে ইস্যু
হ্যাঁ,
করতে
যার
পারি?
যেদিন সুবিধে, ধরো একজন দুজন করে চলে গেলে, গিয়ে কার্ডটা করে নিলে, করে নিয়ে হয়তো একটা বই তুলে আনলে, আবার পরের উইকে সেটা হয়তো জমা করে দিলে, তাহলে তোমাদের একটু সুবিধা হতে পারে। বা কি কি বই আছে দেখে কোনটা ভালো লাগে চেঞ্জ করে দেখতে পারো, তোমরা নিতে পারবে।
ওকে স্যার, থ্যাংক ইউ স্যার।
ওকে, তাহলে আজকে আমরা ক্লাস শেষ করছি। হ্যাঁ,
ঠিক আছে
ওকে স্যার।
ওকে।